Answers for the concreting linear internal practice. Here you will be asked to apply linear algebra in solving problems. So you have to apply linear algebra. Okay, that is what you're going to have to do for an achieved merit and excellence. You're trying to use extended and relational thinking. Here's the problem. So Corey needs to do some concreting for some projects. He has to talk about the costing of these projects. Resources A and B on the next sheet, or down below on the sheet, and actually discuss those. But what you are asked to do is represent the quotes for the three firms in the same representation. So in other words, three graphs, or one graph on three lines. What you are asked to do is then recommend which supply of concrete you should do for two projects, and then talk about valley concrete. Okay, and then excellence question, harder question, how do they change their quote to become cheaper? So here is the resource sheet. So central construction, valley concrete, Warwick premix, and those are the three companies, and these here are the three projects Corey is planning to do. Your first step is to put these onto the one graph. Now to do that, what you really want to do is talk about what am I talking about? So here is my graph. My variable down here is the volume of concrete, and here up here, sorry, on the y-axis is my cost. So if we go back to the resource sheet, it talks about up to so the volume is going to be up to 4 meters cubed. Okay, so you want at least 4 on the x-axis, but try and stretch it out. Try and stretch it a long way. Up on the cost, if you look at those and your cost, we figure out how much it would cost per company for about 4 cubic meters of concrete. I think the largest one's about 1100. So there's your rough scale. Choose a big graph with that as your rough scale. So here I've cheated and used Desmos to give me some nice graphs so we can talk to you about it. Here the blue line is your central construction. Remember they had a formula of C equals 160M plus 230. The red line is valley concreting, I think it was, and the cost for this is 240 M plus 90, and down here is Warwick. Now Warwick's is a little bit tricky, so they've got a cost of 550 when the meterage is between 0 and 2. When it's more than 2, it goes up to 670. So when it's between 2 and sorry, that's 2 and 3, isn't it? Yeah, it's 2 and 3, and so the cost is 790 between 3 and 4, and they won't do anything above 4. Okay, so there's my graph. That's what I've been asked to do. The next question is to talk about which firm we should use for the different projects. Okay, so we look at here, patio 1.4 cubic meters. Okay, here's 1.4 cubic meters. Which is the cheapest firm? So patio, use the red one, which was Valley, wasn't it? Use Valley because it will cost what's that, 240 times 1.4 plus 90, which will cost 426. Okay, we know that because it's the lowest on our graph. For the sleep out, I'll do that in a different colour. For the sleep out, that's at 2.2, so 2.2 is along here. Oh, that one was central construction. So use central because it will cost 160 times 2.2 plus 230 because it will cost $582. And the last one, if you think about the carport 2.6, which is just here, again is still central, and that will cost 160 times 2.6 plus 230, and that will cost $646. Probably should run that down there. Okay, so that's where you're going. Okay, looking at the project, we'll draw a line up from your graph. Here what we're trying to do is we're trying to identify where is it cheaper for Cora to use Valley. So remember the red line was Valley, so it's cheapest from here up until that point there. So it's cheapest for all jobs from 0 meters cubed to, what is that, roughly 1.7 meters cubed. Okay, reading off that graph is your achieved skill. What you would want to do for a merit is actually try and solve those simultaneously. So we've got two equations, C equals 160 m plus 230 and C equals 240 m plus 90. Now at that point just there, they are the same, they are simultaneous. So this C is the same as that C, which in other words means 240 m plus 90 is the same as 160 m plus 230. Now rearrange that and you get 80 m equals 140. Divide both sides by 80 and you're left with m is 1.75. So in other words, at 1.75 cubic meters. Okay, so here what you're trying to do is trying to maximize the profit that they can grab. So you don't want to just go from there down to there and charge the same rate, because that's not going to maximize your profits over here. Okay, so that's the one step. Second step, you can do that by lowering the y-intercept, or in other words the one-off charge. You can do that by lowering the gradient, in other words the per cubic meter charge. You can introduce some sort of piecewise graph, which maybe you want to have a look at that activity on OneNote about that. In other words, there are lots of different answers. It's just a matter of, does yours make sense? Okay.